This is a recording of an active session where we're attempting to shoot trouble inside of what it appears to be a very complex spreadsheet with many tabs, many tasks, lots and lots and lots of procedures in here, some of which are in VBA, some of which are in each tab, but also lots of named ranges, which can cause a little bit of a problem. Sarah and Teresa are allowing us to work with their sheets directly, and let's see how far we can go with this. There's a presenting problem. Sarah, what was the initial presenting problem in your sheet?
So I was successfully able to fix the errors and run the simulation at a threshold of 200. But as I tried to change the threshold to 400 and run that simulation, I saw different errors pop up, and essentially some of the pieces in the workbook just broke.
Okay, good. Bad. By the way, this is a normal occurrence for models like this. Things like that can happen. Let's first check out under formulas. The formulas there. If you go up to the ribbon formulas
Okay.
at the top.
Oh, formulas at the top.
Yeah, those are the ribbons at the very top. Not that. There's something says page layout formulas.
Oh, okay.
Yeah.
Page layout.
No, not that. You want formulas. There we go. And in the middle, find names, name manager, please.
All right, got it.
Now there's a whole bunch of stuff here, obviously, which you probably don't need. For example, all of these A's and all of that, that's going to be for the final project. But if you scroll down and look for MU underscore fresh, THRES, I believe.
Got it.
Okay, now where is that located?
It is located in grid setup C15.
Oh, okay. Why don't we go to grid setup C15?
Okay. Here we are.
Oh, MuseFresh. Okay, and you see that when you hit C15 up in the upper left-hand corner, you have MuseFresh. So that's what should. Okay, if you change that to 300, press enter. Okay,
Yep.
Something should have happened in the grid approximation.
Yeah.
Is it working?
Not really.
Okay, what's it saying?
So I'm seeing some hashtag num exclamation point in some of the cells, not all of them. It's kind of random.
So it works for 200, but not 300. Is that correct?
Correct. And I've even gone back and like put 200 in again, and it fixes itself. But anything else, it doesn't work for.
Okay, now look at the formula.
In the ribbon or
right there. You have a formula right there in this setup. Now, one of the interesting things here is that I think this should have been in the book, and if it wasn't, well, it's now here. That difference between IS, that IS, or what is that? I can't read it.
Yeah, you've got it. It's the $4.
Oh, very good. And mu threshold, that number
Yes.
has to be always positive for this to
Okay.
work. And that's probably why we're getting uh, a numb
But
number.
it's interesting to me because if you look in the cell here of, you know, oh, maybe I'm incorrect. I4.
Yeah, same
It,
problem.
oh, it is positive though. 202.95.
Yeah, minus 300.
Oh, okay. Okay.
Yeah, I
Okay.
think we reset it to 300.
Yeah.
Yeah, so this could be a problem. Um, and one
I
plus
think
a negative number raised to a power is called a complex number, an imaginary number. You might remember that from high school or some other place.
Yeah.
Remember when you solve the quadratic equation? If the parabola does not pass through the um, x-axis, it doesn't solve.
Mhm.
Yeah, the quadratic equation doesn't equal zero. It doesn't work in that real number system. So we actually had to invent a new number system in order to solve that equation. And that's an example of this. So a negative number taken to a power is not even defined in the numbers we're working with here. So one of the things that you would have to do here is say in that formula, you would have to write it um, uh, if this difference, if M threshold is greater than, in this case, I $4, if it's greater than that number, this is an illegal, inadmissible calculation. If it's greater than that number, then uh, uh, make this zero. Okay, that's what's going to happen. Now you see, you do have, I believe you do have observations which are greater than 300, don't you?
Yes. Yes.
And those are working, correct? No, no.
Correct.
Okay.
That is correct. I'm seeing that. Yeah.
Okay. So there's a real easy way out here without rewriting that code, but you could try rewriting the code. Absolutely do that. Save your work. But instead of rewriting the code, you could say, well, instead of 300, use 50, 100, and 200. You can
Okay.
change the rules of the engagement.
Right.
I wouldn't allow the undergraduates to do that, that's for sure. No, never. Yes, I would. Graduate students, yes, absolutely. You can change the rules of the engagement, absolutely. And
Right.
let's see if that works. Did it work?
Beautifully.
Oh my God. Okay,
Wow.
good. So uh, uh, that probably takes care of a lot of issues. The other thing that we can play with, and Teresa, you mentioned this. Uh, I set the grid differently here than what was in the formal assignment, did I not?
yeah, I think I actually ended up changing the formulas in grid approximate because I had the same issue that Sarah's having, and if I added like the if statement when I changed the threshold, I didn't have any problems from that. But
Good.
I was saying like the C is different, but as long as like the hypothesis, we can use this. That makes sense.
Yeah. I mean, in my mind, the hypotheses would be governed on a dashboard by a slide bar where the user, and you'd have to probably put some code behind this. It's just not a matter of programming. It's a matter of thinking through what works, what doesn't work in the model. And we have that problem all the time. This model here is an Excel version, toy version. I got to say it's a toy because you would not put this in, I would not put this in production, but I would buy a couple of really good programmers in something called Qt, qt.com is a good place to look. If you want to be a programmer, there's only 1,000 Qt programmers and probably a demand for 100,000. So just letting you know, okay? It was built by Morgan Stanley Quant back in the late 80s, and he keeps rewriting it and improving it. But this would be the proof of concept that we would use. And this is machine learning 101 right here. This is exactly the kind of model that we do build in machine learning. And actually, instead of the grid approximation, we will choose random combinations of C and sigma, random, and then pull them all together and build this. If you go to XZ sigma grid there, please, Sarah, we would build grids like this, maybe more detailed, and produce pretty pictures. Pretty is a technical term. That means something closer to what the user could use as opposed to just reading a table. Okay, that's part of it. And pretty, this is almost a pretty table. I mean, they use the word pretty. It isn't. This is not what we used to call cosmetic, which had the connotation of nice to have, but why bother, No, must do now, because we have human beings who will consume this information and attempt to use it. And you don't want to confuse them. They didn't build the model, you built the model. So we want to make it as obvious in your face, as obvious as possible. So, okay, so I think what I would do for this, we have two solutions. Sarah, you could easily use the solution by assuming lower grid levels, because the data basically says that.
Right.
Teresa, you solved your problem with code. Would it be all right, Sarah, if Teresa shows her sheet? Would you mind if we see her sheet there?
Oh yeah, absolutely.
Good, thanks.
No problem.
This is a wonderful way to spend Saturday morning. It's better
The
than
best
watching
way.
the cartoons. Okay.
So I had this if statement.
Okay. Oh, great.
So then when I
think
change it, so when I change the threshold to say 300,
yep.
it goes to this. So I get ones all the way up to anything above 300.
Yep.
Okay.
And the one is good because what are we, if you go back, Teresa, to the calculation sheet, that grid approximation, please. There we go. If you put your one of these will do it. ERHD. It's a column S. Is that the product statement? Yes, product. So when you do a product, these are called likelihoods, technically. They don't add up to one. You got to force them to add up to one, but they of themselves, none of these will add up to one. You have to sum them all up and perform the final task in column U to get actual probabilities. Probabilities always have to be between 0 and 1. They always have to add up to 1, and they have to make sense, right?
Mm-hmm.
You have to have a sense of what a high probability should look like and what a low probability should look like. That's typically what we ask ourselves analytically. And what's happening here is that each of these regimes in C and sigma each of these regimes jointly affect one another because you're adding up, dividing by that in order to produce the probability. So it's again, I always tell the story of Google and 43 or 45 million, I forget anymore. How did they, when Google first started, they started searching pages, they used exactly this kind of a system called Bayesian network to search 45 million web pages for a text string. Okay, if the text string was found in a page, it found it. Then it had to rank the plausibility of it, which is what we're doing here. It uses a plausibility, which is the probability. That's an index of plausibility. That's what they did. So, you know, how big is Google now? I can't afford their stock. I don't know about you. You know, rhetorical question out there. Alphabet, right, is the stock now. There's actually two of them, two different voting schemes. But that's how stuff like this starts. Now, they took a technology that was pretty rugged. And when I talked with somebody at Google years and years and years ago, because we're asking questions about the reliability of the searches, and he said, yeah, we built grids like this, just like Yuta Pearl did in a book that he wrote, which is the Book of Why now, on Bayesian networks. And we said, let's try it out and see if it works. And guess what? It worked beautifully. And it provided this capability. Now that product, you had all zeros there instead of ones. You're thinking numerically and correctly so. If you had set the probability, you know, the number to be equal to 0, this product, 1 times the other times the other times the other times the other, would have ended up incorrectly to 0 because it's non-zero. You can see the likelihood is a little bit there. Okay, and what we're interested in is comparing the likelihoods times the priors. They're all equally, so this is really going to be dominated by the likelihood, because we're agnostic as to how often C occurs or sigma occurs, and just as agnostic about how they occur together. Okay, we're very agnostic there. Actually, we needed to do something else there, but it won't matter for what we're doing, because C and sigma are correlated, remember, right? Remember they're correlated? And we had to have a correction for the correlation. Cholesky did all of that stuff in the background. You could go to work. You could sit alongside any rocket scientist at a hedge fund, and if you get into this, that's what they do. The multiplication in T, which is 20.2 times that, whatever number is there, do that in T. Sum up column T, sum the whole thing up, right? See, it's a small number, all very small numbers. Don't get scared by that, because it's a, you can see what happens in the next column. We get some higher probabilities, don't we? 6%, 5%. And then we do an index match to get the rest. Okay, so all that in the background. So this works too. This works too. And if you would highlight that cell for us again, please. It's down here. I see it. Under M5, right? There it is. There we go. Everybody see that cell with the if statement? You can do other if statements. You can also do if error. There's an if error function. If error in this formula, if the thing falls a formula, then comma, set it to a value 1. You can also do that. That's a chief way to do it. But this is great. This is great. All right. I want to ask another question. What was the original problem that each of you faced that you had to fix?
It was really trying to find where the named ranges were to try to get them to link between the tabs.
Okay. Okay. Do you remember which one was giving you extreme agita?
I mean, I just remember this entire sheet was just referenced,
Oh,
and
good.
then this had like no drop down, like it just dropped down to nothing. So I had to go, I forgot where this was, but I think it
That's
was the
that's
claims thing.
interesting that your drop down wasn't working, because my initial issue did start on the same page in the same cell. My drop down worked, but that cell wasn't named in the
Ah,
range. So I had to go back, name it, and then it was like poof, magic, fixed everything.
there we go.
Yeah, I think that's kind of what I think it like dropped down to nothing because there was nothing like for it to have a named range for. So that was kind of my problem.
Yeah, it's also finding where to start. Like, there's all
Yeah.
these different things going on. And it's like, well, where's the first thing to start on? You go back and forth quite a bit. And then once you find that first thing, the rest of it is, pretty straightforward to unravel.
Yeah.
I have exactly the same experience. It depends upon how tired I am, whether I've done my exercises for the day, whether I've eaten or not, as to what my mood will be in finding that needle in the haystack. But the best place to start is, well, right at the error and work backward from there if you can. 99 times out of 100, it's a bad cell reference. That's what ref means. And in our case here, it's because of a named range. I think someone else may have uh, recorded a problem with view underscore threshold, but I couldn't find that either. It was there and doing it correctly. What was incorrect is exactly what you found out, that we were taking a negative number and performing an illegal mathematical operation in Excel. That's all. No big deal, right? So, and now we have two methods of resolving that. One, change the rules of the game. Two, change the rules of the game. So Teresa probably has the more generic approach. Sarah, you're in front of the client. I wouldn't do Teresa's thing in front of the client. Nope, I would do because my fingers would fumble, especially now. I would probably spend half an hour just getting single line typed. But change the range of potential um, scenarios. So what I wanted to get through on this assignment were two things. One, to kind of force the issue of people really trying to understand what's going on in the model, at least mechanically. Okay, I think we can check that box very nicely. And then the second piece, there we go. And then yeah, go ahead.
This is my problem that I was asking Camilla for help for. See how the mu sigma has a different sorry, let me try to get both of these on the same screen. The mu sigma had a different sum product than the one that was on the video. So I just wanted to make sure I was using the right formula. I didn't know if.
Yeah, that's perfectly right. And it should be different.
Okay, so use the one that's in the file. Okay.
But let's think about why it should be different. Every time you change something on this sheet, just, change anything, press enter anywhere, as I think, or F9, make it recalculate. Every time, everything will change.
Definitely.
Products, everything will change.
The number will definitely be different. I think I'm just confused why sig C is raised to has a radical over it, but then in the simulation, it's on mu sigma. So I wanted to make sure that I had the right calculation part, like I'm using the right sum product for that part of it. I didn't know why it was reversed.
Okay, so sigma is a standard deviation.
Hmm.
So it should be raised to the half power. Okay, the
Okay.
sum product should be raised to the half power. If it isn't all the way through, then we got a problem. But that's what it should be, raised to the half power, only because it's a standard deviation. So where we're calculating here are different values of sig c. That's what that is, and sigma. Yeah, I see that. Yeah. Okay, so those are all correct. Those are all.
Okay.
Yep. Yep. And otherwise, it's going to change every time you recalculate.
Hmm. Yeah, that makes sense.
It's just too much fun, isn't it? Are you sure you want to do business analytics or no? This is what I ask every. Oh, I saw R up there. Uh-oh. You have an R expert. Who is that?
Oh, no.
Oh,
That was
that's
my last
you.
class.
That's you. Yeah. 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 Well, I'm going to be sending out a blast today for you taking 611.
The next course?
Yes.
Yes, yeah.
Oh God. How about you, Sarah? You're going to stick around for 611?
I don't think it's in my plans, but you never know. I only have 2 courses left in the program, so
Oh my God. Good. What are the other 2 courses you're taking?
I know that I have to do my capstone course, and then it's business decision making for accounting.
Oh, beautiful. You're an accountant.
Yeah, no.
No.
No, not that either. No.
Very good. Very good. Well, that'll be good. The decision making for accounting is a bit different than 617. A bit. I don't think they're going to do any extreme value anything. The big question about this model that I would pose is I would wonder if this model was better or worse somehow than using the normal distribution, which is what everybody uses. So this is the distribution here is the one used for tail experiences, which is where 99% of the work in life happens when you get surprised. And that's the tail of the distribution. And in business, it's that way too. We nail down budgets, we nail down what normally should happen. That's great. And we just follow the rules. Good. Then we get surprised. All of a sudden, we're not allowed into a market. All of a sudden, our competitors go away, and we have a market, and we are not prepared for it. Things like that, or somebody robs us blind. That happens a lot too. Fraud and cyber, and or all of a sudden we have new regulations that curtail our franchise in a market. Those are the big ones. Let alone the machine breaking all the time. Maybe we have a hurricane. And maybe we evacuated all of the people who can run our plants out of Jacksonville, Mississippi, for safety, and now the plant's just sitting there. And that's what happens to the Clorox companies and the people who make Pine Sol. They used to have the Pine Sol as a solvent. We use it a lot. It smells like a Carolina pine forest. That's the jingle. And they had the mold for the bottle. The bottle is the brand. Like the Coke bottle is the brand. The Pepsi bottle is the brand, literally. And it was located in Hurricane Tornado Alley in Jacksonville, Mississippi. Well, as soon as that was revealed, the vice president of manufacturing went there, took the bottle, made 5 copies, and stashed them in other parts of the country so that they wouldn't lose the brand. These sorts of things happen all the time. So that's why we go to all of this trouble to think about, use this kind of a course to think outside the box for extreme events. That's good. Okay. Did any the macros and the simulation buttons work okay?
Yep.
Yep.
Yeah, I thought so too.
Once I finally got my computer to enable them. you
I know.
know.
What did you have to do, Sarah? What was your experience with getting your computer to enable it?
Go into the security center and, say, yes, I want to enable macros. And essentially, I guess after I enabled everything, I needed to shut it all down and
Yes.
restart it.
That's right.
I had thought that I had done that. I guess I didn't. So I had to do it a time or two before it let me run it and everything was okay.
These platforms are, I'm glad they're safer on the one hand, but if you one false step and you're sunk, you can't do any work, and that's part of the problem. You can always rebuild the model on your own. Right, right. With all those named ranges, that's hard to do. But I know this is a frustrating experience, but it looks like you got through it quite successfully in two different directions. I think you and your groups can write up a little story around how these thresholds change the forecasts, and the forecasts are in that grid approximation. And in the next one, the psi sigma piece, as well as in the EDA for the simulations on the 10,000 ways in which claims can possibly evolve. And I think that's, once you have all of that, you have enough material to tell a story. And that's the bottom line here. Okay. Do you have any other questions?
I don't think so, not at this time. I mean, we have, with these working models and our issues kind of troubleshooted, we have, the basis for, the whole case study.
Beautiful. And I hope this video, which I'll post, it'll take about an hour and a half for it to get it posted. I have to, I'll post it on YouTube and provide a link in the wall for that. So I think that'll work. Okay, probably about an hour and a half before you become stars. I don't know what hashtags to use here. I got to think of some hashtags. Hashtag Sarah, hashtag Teresa, but I don't think you'd want that. I wouldn't want that. We'll try something else. Hashtag troubleshooting.
Yeah, hashtag ref.
Hashtag ref, that's right.
Yes.
Oh my God, that's kind of funny. That's brilliant. Are you in marketing or something?
Yeah.
That's great. No, that's exactly what I should do. And I think that would reach a gazillion people all of a sudden. Hashtag ref. What? You're not showing us exactly how to do everything. Yes. No, we don't do that here. Okay, great. Thanks very much for being able to show up and for sharing your work with us here. And for everybody else, I don't know what their rates are for consultation by the hour, but I think you can contact either Sarah or Teresa, and they can guide you through an engagement letter with rates on it, of course, right? Yeah. Okay, very good. Not so funny. Anyways, we're all paying enough money for the course. I can't think of anything else. And if you're all set, I will bid you adieu. And thanks everybody for your kind attention, and especially thank Sarah and Teresa in dispatches on the wall for their work on behalf of the class. Okay. Take care.
Thank you.
you.
Bye.
Bye.